So again, this is another problem in AMC 10, and it's 2018 AMC 10A problem 22. Let A, B, C, and D be positive integers such that GCD of A and B equals 24, the GCD of B and C equals 36, the GCD of C and D equals 54. And the GCD of D and A is in between 7 and 100 exclusive. Which of the following must be a divisor of A? So A, B, C, D, E, 5 options. So this problem looks, well, kind of simple. Okay, so let's start. Firstly, what clues do the GCD things give us? Because this problem literally is all about GCDs, right? So the GCDs must be really important clues in the problem. So how do we use it to our advantage? Firstly, let's just list out A, B, C, and D. So we know that the GCD of A and B is 24. Now, what does this actually mean? In terms of if we describe it to someone else using language, it basically means that the greatest common divisor of A and B is 24. What's the greatest common divisor? What does it mean? It means that A and B have common factors of 24. So this basically means, 24 is 2 to the power of 3 times 3, right? Both A and B are at least 24. Both A and B are a multiple of 24. And if you multiply this by another number, like for example, W, or, no, I don't like W. I'm going to use big A and big B to make sure they correspond, we don't get this mixed up. So we know that firstly 24 is, A and B are both multiples of 24. Second, big A and big B are co-prime. And then the GCD of B and C are 36. So what does this tell us? This tells us that, what are the factors of 36? 36 is 2 squared times 3 squared. And then we can times big C. Now notice that we have to change this to 3 squared because B is also a multiple of 36, meaning it has to have all the factors 36 has. So it has to have at least 2 squared times 3 squared factor inside. So, and then big B and big C are co-prime. And what about D? D is, GCD CD is 54. Now what's 54? 54 is just 2 times 3 cubed. And then times big D. So what does this actually tell us though? This tells us that C also has a factor of 3 cubed for it to be a multiple of 54. Now the GCD of D and A is between 70 and 100 exclusive. So we have 5 options. So the best way to do this is just test the options because, just make life simple. So right now, if we test 5, so if we test 5 for big A and big D, then if big A equals big D equals 5, we know that the GCD of D and A is going to be at least 30. Okay, so what if we add, let's say, what if we add another 5? So if A equals D equals 25, equals 5 squared, right? But then now the GCD of D and A would be too big to fit in the category. It would be 150, which is, it's definitely too big. So this is too small, this is too big. So I don't think 5 works. So what about 7, which is our second option? If big A equals big D equals 7, the GCD of numbers D and A would be equal to 6 times 7, which is 42, which is a bit too small for 70. Now what about if we have 7 squared? Then the GCD of D and A would be 42 times 7, which is 294. Now that's too big for 100. So that doesn't work either. Now what about, what's the option? Option C is 11. So if A and D are both 11, the GCD of DNA, so if big A and big D are both 11, the GCD of small d and small a equals, well, 66, which is close to 70, but still too small. And 11 squared would be a too big number. So let's try 13, which is the next option. So the GCD of DNA, if big D and big A are 13, would be 13 times 6, which is 78. So, aha, that's actually in our region. So that's just our answer. Now 17, if we try 17, 17 times 6 is just like 102 or something, which is like bigger than 100 already. So 17 doesn't work. So 13 is like the only option over here that works. So that's the answer.